Hello, in this video we're going to go over problem 23 from the 2024 University of Maryland High School Math Competition Part 1, which is a competition that I run every October. For how many pairs of integers m and n with m less than or equal to n less than or equal to 50 and both of them are positive integers do there exist precisely 4 triples of integers x, y, z satisfying the following system: x squared plus y plus z is equal to m, x plus y squared plus z is equal to n. The first thing that I notice is that this z is pretty much redundant. So I can take the two equations and I can subtract maybe the bottom one minus the top one because n is more than m and see what happens. So eliminating z, we would get x plus y squared minus x squared minus y is equal to n minus m. Now we can factor the left side by grouping the terms here like this. We get x minus y plus y minus x times y plus x is equal to n minus m. And that can easily be factored as x minus y times 1 minus x minus y. So this is n minus m. Okay, so we are given that n and m are between 0 and 50. So n and m are fixed, and we want to find out how many pairs of integers x and y there are. Because after we find x and y, then z automatically can be found. So what we need to do is this. We need to write down the left side n minus m as a product a times b, and then we'll have to take one of these, call it a, the other one, call it b, and then see if the solution is going to be an integer for the system x minus y equals a, 1 minus x minus y equals b. Okay, so let's solve this one. If we solve this one, if we add the two equations, we get 1 minus 2y is equal to a plus b. So that means y equals 1 minus a minus b over 2. And then from there we can get x. X is equal to y plus a, which is 1 plus a minus b over 2. So this is y and this is x. So when are these two values x and y are integer? Well, for them to be integer, we need 1 plus a minus b to be even, and 1 minus a minus b is also even. Well, that only happens if a and b have different parity, which means one of them is odd, one of them is even. So we need this. We need precisely one of a or b to be even. So one is odd, one is even. So let's remember what a and b were. We have n minus m equals a times b. We need one of them to be odd, one of them to be even. So one of the consequences of this is that n minus m must be even. Okay, so if I find out how many a's and b's there are, that the product is n minus m and one is even, one is odd, then we figure out how many solutions there are. Well, we can always bring n minus m and break it down into 1 times n minus m. It could be also broken down into negative 1 times n minus or m minus n. And it could be also done as n minus m times 1 and m minus n times negative 1. So these give us 4 solutions. But the question, if we remember, the question was we want to have precisely 4 solutions. Precisely 4 solutions means we don't want any more solutions. Well, if n minus m have an odd factor that is not 1 or negative 1, then we would have another solution. So if n minus m has a prime factor key more than 2, then we have other solutions. Then we can write down n minus m as p times n minus m over p, and then this yields more solutions. So that means we don't want n minus m to have any prime factors that are odd, which means n minus m must be a power of 2. So this is the conclusion here. Now we were also told that n is at least m and at most 50. So now we can run through the possibilities and see what we get. So we need n minus m to be a power of 2. So it could be 2, it could be 4, it could be 8, it could be 16, it could be 32, and nothing else because it's less than or equal to 50. So this means n is m plus 2. M could be anywhere from 1 all the way to 48. So more than 48 gives you beyond something beyond 50. N is m plus 4. So that means m is at least 1 and at least 50 minus 4. So that is 46. So there are 48 possibilities for the first one. For the 6 possibilities for the second one, so let me just write them down here. So 48 possibilities here, 46 possibilities here. The next one tells us that n is m plus 8. M is between 1 and 42. This one tells us n is m plus 16. M is between 1 and 34. 34 and 16 add up to 50. N is m plus 32. M is between 1 and 18. So the possibilities are 42 here, 34 here, and 18 here. So let's add up these numbers, and that should be the answer to the problem. 8 and 6 is 14. We get 16, 20, 28. We have 2 and 4, that is 10, 17, 18. So we get 188 possibilities. So the answer is D.